Hello, folks. Welcome to Rational Science, the only site on the on the internet that does physics rationally. Everybody else moves concepts around, and that distinguishes them from us. We call these people flatlanders or just plain idiots. Okay, what is an idiot? Idiot is a person who has big ideas. Comes from the Klingon idea. Everybody has normal ideas, and these people have idiots. So they have big ideas. And we have all kinds of people. We have Timmy Dilate. He believes that time dilates and plays around with time. We have Flux the Ether, and he moves the ether around. All these concepts. Dense Danny, flat earther there, representative from the electric universe, Eddie Thunderbolts, and so on. So we have all these people, and they have big ideas, okay? And they have different way of thinking than we do, for sure. And yeah, what we have is really a paradigm shift here, and this is what the typical idiot believes in. Typical idiot moves concepts such as field and wave, plasma, electricity. They move the electricity, even though electricity is the movement, according to them, according to the definitions. Electricity is the movement of some kind of particle. And so they move the movement of particles. That's essentially what electricity is. Flat earthers, they move the density. They say density is the one that causes things to move downwards, gravity. Black hole, dark matter, singularity, all these things move. All these concepts move. They move the function, the wave functions, some call it. They move energy, mass, time, the whole works. Okay? They also typically like to run experiments. And no, we do not run experiments in science. Let me say that again in case you say it was a slip of the tongue. We do not run experiments in science. In science, what we do is we explain results of the experiments. Okay? You can run all the experiments you want in your dark basement. When you come to the conference, you need to explain how it happened. What was the mechanism? Okay? That's what science is. But running experiments, anybody can run an experiment and not understand anything. A flat earther or a flatlander or idiot also attempts to prove theories. Okay, they're into proof, in fact, and truth. They use those words. And they introduce belief, which is another synonym of knowledge, and opinion. They introduce these subjective things into science. Okay, so yeah, they differ a little bit from us. We do not do anything like that here in this site, and that distinguishes us from everybody else on the planet. Okay, so if you happen to come to this site, well, you'll find a little bit of a paradigm shift here. We have a different way of looking at science. Okay, and it might scare you off because you were probably educated in a different way in high school or college. And so just be aware that this site has a different version of science, proposes a different version of science, and therefore of physics, right? It's got nothing to do with math. It's got nothing to do with experiments. It has to do with explanations. You need to explain a mechanism in physics if you want to be a physicist. Otherwise, you are a mathematician. We call them mathematicians. Okay. Anyways, I turned 70 yesterday. 7 decades. Okay. You might say, well, how do you define 70? Well, what is 70? And I can only say a way of concisely stating it is hair starts to grow where it's not supposed to. That's essentially what 70 is. And yeah, hopefully you don't make it to 70 because, or even later, because you have all kinds of problems. In my case, I get arthritis. can't even move my fingers anymore almost, you know. Can't play guitar. Used to play better, but now the fingers are molasses. They move a lot slower. And other people have other problems. So if you're in your 20s, don't look forward to it. There's no future in aging, okay? Okay, now the question is, will I live? Here we're going to talk a little bit about extinction. And the question is, you know, I'm 70. Will I live another 10 years? Will I live another decade? And there's two possibilities. One that at least in that context, right? One is that I won't make it to 80 because I died earlier for whatever reason. And another one is that maybe the global economy collapses as we propose here, and we have the extinction of man, and I'm included within that species. In other words, which will come first? My regular death, the one that maybe Mother Nature scheduled for me, you know, because my bones don't make it to the age of 80, or will it be the collapse of the global economy? That's the issue, okay? And for this, I'm going to start by invoking a gentleman who was my hero a long time ago, about 40 years ago, to be pretty correct about it. His name was Carl Sagan. Okay, and I was admire of Carl Sagan primarily because he had good teaching techniques. Okay, he was a guy who talked calmly and so on, and that's something I envy in him. You know, I'm a hothead. I use words like idiots, which I invented, you know, and they're not in the dictionary, so don't look them up. And he probably wouldn't use that in public speaking, right? He was a little more gentleman-like than I am. Okay, so Carl Sagan, he was one of my heroes, right? And but I stopped having him as a hero because even though he was a great teacher, and I think all of you who knew him or heard him or saw him will agree with me that he talked, you know, calmly and got his points across. Why did I stop being an admirer? And now I'm even embarrassed that I was an admirer of his. Because he talked nonsense. Everything that came out of his mouth was absolute bunk, nonsense, poppycock, everything. Okay, and here let me just point out a couple issues. Okay, he became essentially a caricature of science, as far as I'm concerned. Okay, he vouched for quantum mechanics, general relativity, and string theory, all three of which are bunk, nonsense. The explanations given in these three religions, they're not even religions. I don't know what to call them. They're irrationalities. They're all irrational. All the explanations given by these people are irrational. And they don't even, they're not even embarrassed by it. They think that humans are not supposed to understand how the universe works, that our minds are a little different than Father Universe's, so we don't think like he does, so we can't understand him, he doesn't understand us, and that's okay because we're just petty humans, etc., etc., etc. Some people believe out there, some of these idiots, that humans will never discover how this universe works. It's just too grand, too infinite, too big, and we're so puny, our minds cannot comprehend it all. This is what these people have been taught, or this is what they've been led to believe. This is what they believe in. Okay? And I think Sagan was somewhere in there. I can't say that he was really in there, but he did vouch for quantum mechanics, general relativity, especially those two, mathematical physics in general. And all the explanations there are bunk. If you looked at his series Cosmos, it's a synthesis of these of mathematical physics essentially. Okay, and yeah, mathematical physics is total bunk, nonsense. Okay, we don't care about the equations. We want to know the explanations of how the universe works. And in the end, they always say, well, that's philosophy. Anyways, ontology, metaphysics, whatever they call it, they dismiss it. And so, like I wrote a paper the other day in Quora, why did they even attempt to explain um, you know, how this universe works? Why didn't they try to give an explanation a physical interpretation to their equations if they're at the end going to say, well, by the way, because when you challenge them, you say, well, hold it, you said some nonsense there. Yeah, all that is philosophy anyways. It's not part of physics, not part of science. So, if you want to know how a magnet attracts another, they say, well, that's philosophy. Yeah, just like you heard it. They say that's not part of physics, that's not part of science, because we'll never know, and the mind of Father Universe is very different than ours. We don't comprehend his ways, and blah blah blah. All they want is measurement and equations, and they call that science descriptions. The other thing I objected to Carl Sagan eventually, because I was there as well. He was an atheist, and I used to be an atheist. And have I become a Christian or a Muslim or a Buddhist? No. I became a scientist, and a scientist rejects atheism, theism, and agnosticism, all three of which are religion. Okay? Why? Because they introduced the word belief into their discussion, into their debates. So, a theist might say, I believe in the existence of God. And the atheist might say, I don't believe in the existence of God. And I don't think there is a God. Anyway, they want to say it. I've proven, I know for a fact that God does not exist. And agnostic might say, well, I don't know if God exists. I haven't made up my mind. I don't know what tests we could run to prove the existence of God. All these three lines of thought are irrational. All we had to do all these years was define the word exist. Of course, you got to define the word God, but more basic yet is the word exist. What does exist mean? And no one in the last 3,000 years defined the word exist, and so they've been running around in circles saying, well, God exists. No, God doesn't exist. Well, what did you mean by exist? Oh, we don't know, but God exists. So this was the problem. But then the other issue is that Carl Sagan was involved with SETI, and this is the Search for Extraterrestrial Intelligence. In fact, yeah, he was one of the guys who sent a little thingy out there with the one of the probes to see if maybe the Martians somewhere in the universe could get a hold of it and know that we're here. Where they try to give them directions to our planet. So he believed that not only were there people out there, which is very likely, right? People like us, intelligent beings, right? But not only that, there are beings out there, but that maybe we have a chance of contacting them. And for this, you have this search for extraterrestrial intelligence, and they listen in to see if they can hear or, somehow pick up waves coming from another planet. Okay, some signal that someone sends us, the bottle in the ocean kind of thing. Okay, and in that regard, again, I think he wasted his time. I don't think there's any chance whatsoever that we will ever hear of another civilization. The good part about that, which is the one I will credit Sagan with, and I'll still stand behind him on that, is that he made a little comment. He said, can you imagine if we were to contact another civilization? We finally made contact with another civilization. Can you imagine that? Someone talking to us from another planet somehow, that we communicate and we try to figure out their language and etc. And we eventually end up talking somehow, even though they're far away. And this would be interesting for one thing that Carl Sagan mentioned, and that was that it kind of would unite the world. Okay, so today you have three empires, and these are the three empires that we have today. We have the Russians, we have the Chinese, and we have the Americans, and they have each either strong military or strong economics, and so they are the ones who essentially govern the planet. We have three empires today. And yeah, they look more or less like this. Okay, here we have the three empires. Okay, Russia, United States, and China. And right now, these three groups essentially don't trust each other, and they might even go to war further on. And what if Mr. Sagan was correct, and instead of competing and fighting, you know, they work together, and they would work together. Maybe because we contacted another civilization, like Carl Sagan says. I don't think that will ever happen. But what if there were other reasons? What if we realized that we're the last humans on Earth, and the heads of state kind of came down and said, "Okay, hold it. If we're the last humans on Earth, maybe if we work together, we might able to maybe not avoid extinction, which I think is impossible to avoid it, but maybe work together to prolong our stay on the planet. What things could they do?" Okay, so this is what I have in mind. Okay, is there anything that governments can do? And let's see if I can give you a hint of what they might be able to do. Here it is. Okay, let me make this smaller here. I don't know why it's so big. Give me a second here. There we go. And these are three things that maybe governments could do if they work together. Okay, we're not talking about the rich here. We're talking about implementing some kind of policy that would prolong the lives of humans. I'm suggesting that we should not have any more babies. Tell women, hey, we recommend that you have no more babies. You say, Bill, that goes against your theory, doesn't it? I mean, we need more consumers, right? Well, right now we're producing consumers for services. That's all we're doing. We're creating more and more services and not producing any real stuff. In other words, the real stuff, the tangible stuff, is becoming a smaller and smaller percentage of global economics. What is growing is services, and within services, not the hands-on services like barbering and landscaping, stuff like that. What's growing now is internet services. Everybody just opens up a YouTube channel or whatever channel, Instagram, and they try to make a buck, getting ads primarily, And so and what are these services? They are all entertainment. They're geared towards entertainment. We're running the world on entertainment. Is that why we want to bring new generations of children into the world, so that we have a world, they live on a world of entertainment? No, we cannot run the world on entertainment. We are headed to extinction. And all I'm saying is let's prolong it, and therefore we have to make some drastic decisions, one of which is let's stop having babies, so that those who are alive today can live off their lives as far as we can, and we will not have a new generation of babies to grow up and to simply become extinct very, very early in life. That would be more of a tragedy, in my opinion, than not having them to begin with. That's one suggestion. Okay, I know you'll kill me or wring my neck for that. No problem. I'm just giving you my opinion of what would prolong, okay, the our species from dying sooner. That's the issue. Found new cities. I just came from Argentina, and that's my country, and it's a big country. It's an empty country. It's only got 45 million people. It's the eighth biggest country in the world, and the whole South Patagonia is empty land. What if we could take some of the people from the cities and found new cities out, the existing people, right? Not create new ones, but just move them from the cities with some kind of incentive so that they go to the middle of nowhere, give them land, and instead of, producing services, goods would be okay, but not services, but instead of that, have them produce agriculture, or, cattle ranching or whatever. Canada, empty country. Australia, empty country. Russia, empty country. We have lots of empty land on the planet, and our population is really declining. But right now, not only is the population declining, what we have declining is something else. We have the decline of manufacturing. Okay, this is global, and you can see manufacturing is going down. The rate at which we're producing tangible stuff is going down. We say, well, services are becoming a bigger percentage of the global economy, but it turns out that services are also going down. At least they were until 2020. And I think that the whole global economy is gradually coming to a grind. You know, it's to a friction. There's a lot of friction, and coming to a stop. Okay, and part of it has to do with the fact that we're not producing children, and I've shown that before. Here it is one more time. Population growth rates are scheduled to go down. They have been going down since 1963, the last time we had the highest level, which was about 2.3 global population growth rate, right? And now we're down to 1. I think we're below 1 right now in the year 2020, 2022, thereabouts. And by mid-century, it's supposed to be somewhere mid-century, we're supposed to reach zero population growth. Okay, and that's bad because it means there will be no demand in the future, and that means it's going to take us to a point where a lot of companies will fold. Okay, that's what I predict will happen to the global economy. I don't think we can avoid it. And so what I'm suggesting really is that we have stop it today. If I were the dictator on earth, I would recommend, not dictate, but recommend that people stop having babies, produce agriculture in new cities, new towns, you know, like in the Old West, so to speak, if we could manage that. Of course, I'm dreaming out loud. I'm convinced that cannot happen. I'm just saying that it would be nice for it to happen because that might change the length of time humans live on the planet. That's all I'm suggesting. There's a book I read some time ago. It's known as Grow or Die. It applies to any economic system, whether it's a company, country, or the world. Okay, you have to grow or you die. And right now we're on the path of death because everything is coming down. Services, manufacturing, the growth rate of the economic growth rate as well as the population growth rate, both are coming down. The rates are becoming, you know, smaller and smaller and smaller. And this fellow says the following, says Dr. Land's theory of transformation, a cornerstone in the strategic planning and organizational transformation of corporations. But he says, at the root of the principle lies a single concept, growth. You have to have growth. The most basic and universal of drives through which all biological, physical, chemical, psychological, and cultural processes are intrinsically equivalent. You have to have growth. You don't have growth, you die. Okay? So all I can say is we're not growing right now, so I think we're on the path for extinction. Okay, someone might say, well, how soon will that happen? Okay, and here it is. This is what I've suggest the picture, our economic picture looks like throughout the ages. Let's assume we were born as a species anywhere from 200 to 300,000 years ago, okay, whatever, it doesn't matter really. But we lived a long time, very long time as hunter-gatherers, okay, primarily hunting. You can say at least 100 or 200,000 years we were hunter-gatherers, even before then. But then about 10,000 years ago or thereabouts, we went into farming agriculture. 200 years ago, we went into the industrialization phase, manufacturing. People moved from the country to the cities. The cities grew, they produced machinery for the country, and the country was able to become more and more efficient without so many farmers working in the land. Then about maybe, I'd say more like 40 years now, about 1980, services took over and they started becoming a bigger percentage of the of the GDP in advanced nations. And today we've gone even beyond that because now we have certain, not only services are maybe around 85% of some of these countries' GDP and workforce, but a lot of that is now being shifted to a new kind of service, which is internet services. And so my take on that is that services are another word for unemployment. Okay, service is an abstract production of whatever, of nothing, of abstractions. You're not producing anything. All we're doing is trading with each other. You know, I scratch your back, you scratch someone else's back, and that guy scratches the third guy's back. All we're doing is scratching each other's backs. And I'm not sure the few who produce goods, especially food, uh, as long as, how long can we continue just doing services, waving my hand and I get food somewhere, from God. Someone gives it to me, someone produces it and brings it to me. How long can we continue with this? For the next million years? Okay, and so I'm saying that cannot be sustained. It's impossible. Okay, and of course, some people object to my theory, saying, "Bill, you're crazy." Okay, I'll accept that as an objection. Uh, Primarily, I say the people who object to it are the microeconomists. They don't care about macro stuff. I'm a macroeconomist by nature, but all these people are microeconomists. They want to know how to make money themselves, how they can get into Bitcoin or trade with their neighbor without having the government intervene in their affairs, like through taxation or anything like that. They want freedom from government, and so they don't realize that macro trumps micro every day. Macro is the big one, is the strategy. Micro is the tactics, you could say. And no, I think macro trumps micro. So the majority of people who object are what I call narco capitalists, anarcho capitalists, narco caps. They're the new communists, really anarchists. They don't want government, but not in the sense of 19th century where they threw bombs. The anarchists did their own politics, individual politics. They threw bombs. Now these people are not like that. At least not all of them, or most of them. No, they just want government off their backs, and they think that as long as you can take government off your back, I can get along with my neighbor and trade with him and so on. They think they can run the world like this. Everybody just taking care of themselves without a government. What can I say? No. Okay, so these are the people I think that object to a lot of my theories, and no problem. We all have different opinions about how, or theories of how this world is run and how it should be run and that kind of thing. Okay, and my concentration is on extinction and not on politics or specifically economics, only as they relate to extinction. And so one fellow says the following, he says, "How do you think modern society can even exist without money today?" Yeah, you got it. You understood it. Yeah, modern society cannot live without money today. Okay, so you said it right. You just probably didn't understand what you said. Okay, that's the point. The point is that if money goes out, we can't not run the world. So we had better trust in God, like the dollar bill says, because the day we lose our faith in money, we're all dead. Okay, so we have this abstraction that keeps us all alive. Okay, and this abstraction is simply, oh, I want money, I want gold, I want crypto, I want whatever, dollar bills, give it to me and I'll take it. Why? Because I can unload it to someone else. Or I know, or I believe that I can unload it to someone else tomorrow. That's why I want it. That's why, I crave it, right? Question is, what happens the day that you cannot unload it because you don't want it, or no one wants it? When money is no more because we all lost faith in money. I mean, we have inflation eating money every day. And I always give the example. If I gave you're selling your hat, and I say, how much you want for it? And you say, I'll take $10. Okay, I'll give you $10 in Vietnamese money. Will you take it? You might say, well, no, I don't want Vietnamese money. I can't do anything with it. Well, I thought money was money was money. I mean, it's guaranteed by the Vietnamese government. Why don't you want it? Well, because money is not money is not money, and some money we don't want. Eh? Sure, you don't want Argentine pesos. They're devalued. And fellow says the world's filthy rich capitalists will always find a way to keep it running. And no, they can't do anything about it. Extinction is something. It's unavoidable. It's in the cards. It was in the cards since from the moment Mother Nature made us, made our species. Whenever that was, 200, 300,000 years ago, it was already in the cards. Our intelligence would take us to develop all these different systems, uh, money. First it was bartering, then we went to gold or coins of different silver and so on. Then we went to some kind of paper money, IOUs and so on. Then we moved into crypto today and so on. And people think it's a question of replacing green money with brown money. No, this is not an issue of money. It's the issue here is that you cannot continue giving people bonuses and freebies so that they can reach the end of the month. And when people are out of work, either they break windows and burn tires, or you give them money and keep them happy. And so the governments are now creating money, lots of places on the planet, and just giving it to people so that they don't go out into the streets. And the less work there is, the more unemployment or the less employment there is, and the more the government has to fill in that hole by creating money. And that's what's happening across almost every country on the planet right now. Just pick your country and you'll find the same thing. They're just creating money and giving it to people. And I'm not sure that you can do that. The fewer and fewer workers maintain ever greater and greater people who live off the system, off the grid. That's got to crash at some point. At least that's my theory, saying that we cannot avoid it. Okay? And someone says a global economic collapse isn't what happened to the dinosaurs. Absolutely, yes, that is what happened. All animals have economics. They all manage one resource specifically, and that is food. I don't know any animal that does not manage food. And that's what economics is, it's the management of resources. Okay, so all animals manage food, and carnivores manage the herbivores, and the herbivores manage whatever's on the floor, green plants. And what happens is that the green plants disappear, the ones that the herbivores ate, and that takes care of the herbivores, which indirectly takes care of the carnivores. That's what happens in a mass extinction. Plants disappear. Why? Because they went through their cycle, their millions of years cycle, and at some point they got to go. When you got to go, you got to go. Humans are omnivores, has nothing to do with it. Humans can process pretty much anything into food. Again, nothing to do with the theory. This is not an issue of whether we can eat anything that's out there. This is an issue of when, not if, but when the global economy collapses, when money is no more, trade is no more, there is no commerce, everyone's on his own. When everyone is on his own, people will be killing each other. But I'm getting ahead of myself because here's another fellow who says the following. He says just get some ranch and you have a salad. Plant something. The guy thinks he's going to be living, in California with some kind of land there, and says, oh, I'll just plant my own food and have my own cows and my pigs, and I'll live on the farm just like, the old-fashioned way. No. when the global economy collapses, you'll be a farmer by day and a soldier by night, like in the hoplites, Greek hoplites. The guy, what was it? In the winter, they would go and fight. In the summer, they would plant. That was more or less the general feel. In other words, the farmer was a fighter also, was a gladiator on the field. Yeah, he was needed in the army. And of course, a lot of them were slaves, but everybody did agriculture in those days. And no, if when the global economy collapses, you're going to have to defend your land because other people will not be planting. They'll be stealing and killing and murdering and cannibalizing. Okay, they'll be eating you. So you're going to have to defend your land against thousands of people from the cities who know nothing about planning. So you say, well, I'm just going to retire, good Mar-a-Lago kind of thing, your own plantation, your own farm. Think again. You're going to be fighting 99% of the time, and whether you have any time to plant and to harvest, I don't know. That's up in the air. You will be fighting for your land. You'll be fighting for your life, and more than likely, you'll be stealing and killing just like everybody else. So no, this notion that you're gonna have your own salad, your own lettuce, tomato, I don't think so. Okay, and a final comment person says Martin Armstrong said this in 2014. Well, I looked this fellow up. I didn't know him, and no, all I can tell you is this fellow Armstrong. All he talked about is cycles. He said there are cycles, and he just put a number to it. Like he says, like it's 8.4, 8.6 years, and things repeat themselves. Nothing. Yeah, he didn't say anything about extinction for sure, and he just talked about cycles. And I'm saying the cycles end someday. The last cycle is the one that takes us into extinction. Okay? Not because I'm pessimistic, but because I'm realistic. Okay? Okay, let's get on with the subject matter of today, and that is the graviton. Okay? What is the graviton? Here, let's see if I can get it. I'll start with this. I'll say that most humans are mathematicians. I'd say at least 95% of humans on Earth are mathematicians. And only about 5% are physicists. They think in physical terms. They are rational people. The majority of people think in terms of spirits, and those people who in the past used to think in terms of spirits, ghosts, gods, angels, that sort of thing, they moved into something new, which is, concepts, abstract concepts. They believe in fields, in mass, in energy, and they move these things around thinking they're things. And that makes it different, which is what I was talking about earlier when I started today, the introduction. Okay, and here it is, more or less. 95% of humanity, they're mathematicians. Traditional mathematicians, they work with spirits, angels, gods, The modern mathematicians, they move concepts around. They think concepts cause things to happen. And so all the physical interpretations are mediated by abstract mathematical concepts. On the other hand, 5% of humanity are physicists, and physicists are people who believe or who have the sense or theorize that Mother Nature does not work with concepts or with spirits, that there are objects there that we cannot see or touch. And an object that we cannot see or touch is not the same thing as a concept. Object that we cannot see or touch is not the same as a spirit or a god. Okay? So mathematicians essentially believe in black magic, whereas the physicists think that Mother Nature is simply messing around with us. She's fooling us. She's doing a magic trick. She's not showing you what's in that invisible world of hers. That's all that there is. But there had better be something in there. Okay? We would like to think that Mother Nature looks something like this. Okay? Cute little girl. Okay? That's nice, naive. This is Mother Nature. She loves us. Okay. Mathematicians have a different version. They think that Mother Nature does black magic. She's a mean old witch. Okay, I don't know. You might want to consider which side you're on. Do you believe that Mother Nature is fooling us, or does she actually do black magic? And here, let me give you an example. Okay, here it is. Okay? You go to the show, and there's a magician on stage, and you see this. Okay, guy moves his magic wand, and he makes a rabbit disappear. Okay, or appear. I'm sorry. There he is, disappear, moves it around. Okay, wand around, and the rabbit appears. Okay, simple. Okay, a lot of you saw tricks similar to this one, right? And so you ask the mathematician next to you, how did he do that? And the guy says, well, he made it appear from the void. They actually believe that, the rabbit was made from nothing. You have the quantum mechanics, mechanickers, right? And they believe, or they theorize, right, that particles come in from the void. You have the general relativists, and they believe that matter, the universe, so to speak, right? In fact, space and matter, right, had a beginning. There was a start. It came from nothing, which is what space is, nothing. But they say space came from nothing too, I guess, right? Because space is something in their view. So space, the something space, as well as the something matter, both space and matter, they came from absolutely nothing. And they have no problem believing in this, in theorizing like this. And they'll tell you this in your face. And so, yeah, they believe that the rabbit came out of nothing. And they'll tell you, yeah, and they have no problem believing this. They have no problem theorizing like this. Now, they don't lose any sleep over this. And so, yeah, it kind of worries you because you say, how can it possibly be that these people went to college 10 years and more, they're professionals, and they actually theorize, they propose the physical interpretations include the appearance of something out of nothing, matter out of space, not even space, I can't even say space because even space came out of space, or better yet to say space is a something that came out of nothing, whatever nothing is, because they never define nothing, they never define space. They just say it's infinite, it's made out of particles, and there's energy in there, and blah blah blah. They fix the problem that way. Okay, but this is what they believe. That's what a mathematician believes, and 95% of humanity are mathematicians, and only about 5% are rational humans. We call them physicists. Okay, and last week I talked about this, the fact that you have the Higgs. What is the Higgs? Well, you can think of it as a bunch of fish going through the ocean. And the Higgs is a particle of mass that goes through a field known as the Higgs field, the ocean in this case, right? And some fish move easier through this ocean, and some fish or have a hard time getting through there. Those that have a hard time, they weigh a lot, okay? And those that are thin, I guess, or have less volume or whatever, weigh less, they move easier through the river or through the ocean, and because of that, they have less mass. This is the notion they have. So mass is a question of interaction, according to the Higgs version, right? And you could say that the Higgs is the opposite of the graviton, because whereas the graviton causes gravity, the Higgs kind of opposes gravity. It has this inertia. It scrapes its shoulder or its elbow against this ocean, right? And so we have, on the one hand, you have the gravitons, I guess you could say the field of gravitons, the particles that form this ocean, and and you have the fish moving against the ocean, and it interacts with it, and because of that interaction, we have the particle of mass and the particle of gravity, the graviton. I guess that's the best way I can put it because they never really visualize it. It's all math. And we're trying to visualize it because we're trying to figure out how this universe works. How does gravity work, especially at the quantum level? Okay, so that's what we're trying to explain here. We're trying to visualize it. We're trying to imagine what these people are talking about, trying to make a movie of it in our mind, right? Okay, what's the problem with that? Well, with the so-called Higgs. Well, it's a particle of mass, but mass is defined as the quantity of matter, or a measure of the quantity of matter. So we're talking about quantity of matter. We're talking about number of particles. We're talking about counting marbles. Okay, we're saying in this case we have 12 marbles. That's the mass of that object that you see there. It's a 12 marble object. Then we all understand. We say, okay, 12 marbles here, 20 over there, 100 over there. We understand that. Weight, on the other hand, is a measurement. It's not counting. It's got to do with measuring. Okay? And what you're measuring is a resistance of some kind, an interaction. So the particle of mass, known as the Higgs, is actually a particle of weight because it's defined, the Higgs is defined as an interaction of the Higgs particle with a field. There's some kind of interaction there, and there's resistance, there's some kind of, I guess, friction, whatever you want to call it. And because of that, the particle has mass, and that mass somehow is transferred to other particles. If you can try to visualize that. They do it mathematically. We don't care about that. We want to know how it works in real life. And of course, they cannot visualize that. But my point here is that the Higgs is, like I said the other day, it's a particle of weight because it has to do with interaction. It doesn't have to do with counting, which is what mass is defined as. Okay? And of course, they had to define mass in different ways to incorporate weight into the definition of mass. That's what I'm saying. Mass and weight are exactly the same until the mathematicians are able to separate one from the other through a definition, first of all, right? And then, they determine mass by weighing. So right now, we can't tell the difference. They say, look, if you take the Legrand kilo, that used to be the standard of mass in France, right? If we take Legrand all the way to the moon, it's going to weigh less. And we say the weight changed, but not the mass. But the mass changed because what we're going to do on the moon is weigh it. We don't know how many atoms or hydrogen atoms, unit of mass, the Grand Kilo had here on Earth, and we don't count them. We just took and weighed it. And so, it weighs differently. That means that the mass also changed because we determine mass by weighing. So we haven't learned much with the difference between mass and weight. Okay, so here we have a simple trick that I sometimes do here. Here you have a spoon, okay, and I'm going to drop it, okay. In fact, I didn't drop it. What I did was just let go of it, okay. I didn't push it downwards, and then somehow it falls to the ground. It doesn't fall to the ceiling. How do you do it with gravitons, which is the quantum proposal? Well, you let go of it, and it goes down. So you think that the only way that can be done is something pushing it from above. I don't think you could have particles pulling it from below. How do you pull with particles? It's got to be a push mechanism with particles. You can't pull with particles, no matter how you say it. Now, you can have this shadow effect like Lesage and so on, no problem. But it's always going to be a push of some kind, okay? So we're talking about push gravity when you're talking about gravitons, okay? And here it is, more or less, illustrated, okay? You have the green pixels, as our science critic suggested once. You have all these particles pushing the spoon downwards. We can all understand that, okay? It's got a lot of problems because, you say, why are the particles directed downwards? Okay, why aren't they upwards? Why aren't they sideways? What happens to those particles? But we can understand the mechanism if someone says, look, the spoon came down because particles pushed it down. Okay, we understand the mechanism. No problem whatsoever. The problem now is that that's the quantum version, assuming. There are other versions, but I'm just going with one of them, which is gravitons pushing it downwards. Okay. Here's the general relativity version, which does not include particles, which does not include force, in fact. Okay. Here's the general relativity version. Okay. You have a spoon, and it just is pulled down, I guess, because the canvas, the space-time canvas, so-called four-dimensional space-time canvas, goes downwards. Okay, so either it creates a hole and the spoon just falls in that hole, or the spoon itself is pushing it down. Who knows? But the point is, this would be something similar to this would be what the general relativistic version would be. And so, how do you reconcile these two versions? You have, on the one hand, the particles pushing it down, and here you have the general relativity pulling down, where the canvas falls underneath the feet of the of the spoon. You cannot reconcile these two versions. So even if they get all the math together and they figure out, how gravity works in the quantum world, and they figure out the gravity, the graviton, what it is, a bunch of particles pushing it down, or transferring negative momentum, or any of that, that mechanism is irreconcilable with what we have in general relativity, which is the space-time canvas mechanism, which is why Einstein became a hero in 1919 when Mr. Arthur Eddington proved that Einstein's theory was correct. So we have these two mechanisms, and they're different. They cannot be reconciled, and so we have a problem, because it means that even if these people who are researching, in the case of general relativity and in the case of quantum, they're researching gravity, they're never going to put the quantum world equal to the general relativistic world. It cannot be reconciled. Okay, and so what happens here? We have the middle version, the one that has been growing maybe in the last 40 years. They're trying to get away from the particle, and they're trying to get away from the canvas, so to speak. And the way they get away from that is they made ever more popular, stronger, the theory of fields. Okay, so they're all regions, not only the general relativists and the quantum mechanics, but also the string theorists. They're all working with fields. Why? Because the field is a very, you could say, accommodating entity. On the one hand, they say the local vibration of a field is a particle. But at the same time, the field, what is a field? Well, it extends all the way to the edges of space-time. So you have the best of both worlds. The field represents two things. The localized vibration, which is a particle, a point or whatever you want to call that, and also it extends all the way to the edge of space-time. So it's got the discrete and the extended all in one. That's why they love the field. So the field, you can hear all these people these days talk about field, quantum field theory. General relativity, it's a field theory also. So everything is a field now. Okay, and so here's the vibration, local vibration of the field. Okay, I showed it for the Higgs the other day. I'm going to show it also for the graviton, because there's no difference. They're gonna say that L particles are just local vibrations of the field, and so there you have a graviton. That's what a graviton looks like. You always wanted to know? There you have it. That's what a graviton looks like. Don't look for it in the standard model of quantum mechanics. You won't find it there. They don't have the G for graviton. That's why it's not in the standard model. But here you see it. This place always illustrates everything. We illustrated graviton for you. That's what it looks like, okay? And here's what a bunch of gravitons look like, okay? More or less like that. You can see all the you see the field, which is the whole thing, the whole shebang. And then you also see the local vibrations of each field or regions of the field. And so we have both particle and we have also extended field all in one shot. Okay, so this is what they love. They love this thing called field, because it gives them the best of both worlds. On the one hand, they say, look, it's a local vibration of the field. And you say, oh, that's a particle. And you go home happy because they explained the particle to you. And you say, well, how about, how does this influence that over there? Well, see, it's part of the field. It's part of the ocean, extended ocean. And so this fish, which is simply actually a wave of the ocean, not a fish, like a separate entity. It's a vibration of the ocean itself, which is a wave, and this wave affects that wave over there through the ocean, through other waves, I guess. So wave affects wave through the waves. And what are the waves? The waves is the motion of the ocean. That's more or less the notion of a field. That's why they love the word field. So let's look up the word field, and we find some problems here. Here we find that field is a quantity. It's represented by a number that has a value for each point in space and time. And there you see what each one of those words mean. Okay, but essentially a field is just a number. That's it. It's a bunch of numbers. And when they say that the field is vibrating, what they're saying is that the numbers themselves are vibrating. That's what these people are actually saying. So we have a problem because they're not talking physics, they're talking mathematics. And they don't even realize that anymore, because they've always thought of a field as a region where something is happening, and they say there's a something in there, in the field. Whether it's a magnetic field or a gravitational field or electric field, something is in there. But it's that something that they've never identified. And so what they've done is they said, well, we don't care what it is, because a mathematician doesn't care what's in there. He just says, look, we can measure the strength of the field locally in each one of those spaces. And we say, here it's stronger and here it's weaker. That's all they care about. And they say, here it's so many, whatever newtons or whatever, if it's a gravitational field. They can tell you what the strength of the field is at different points in that region. But they cannot identify the invisible, intangible things that are causing that effect. Okay? And so one fellow says here, he sends me a note or a comment, and he says, field is a mathematical representation, regional differences in strength. Exactly, that's all it is. It's a bunch of abstractions. Well, we're talking about a bunch of numbers that are moving, are vibrating. So yeah, it is a mathematical representation. It's just regional differences in strength, and that is not a physical object. What this fellow mentioned here is a concept, and we cannot do physics with abstract concepts. So for all those who try to do that, they are what do we call them? Flatlanders. That's what we call them. Okay, we had our science critic, and he made a video criticizing the scientific method. Incredible. But he's allowed to do that, and we're answering piece by piece everything that he mentioned, because he essentially addressed every topic. So it was a good way of addressing, his objections, making a video on each one of his objections. And in this case, he did the definition of life. He is of the opinion that the word life has been defined by biologists, and all I had to do was look it up instead of making a fool of myself. Yeah, okay. Sometimes I want to make a fool of myself because I want to make a point, and the point is that no one has ever defined the word life. What is biology? The study of life, or so they say. Means we don't have any biologist on planet Earth, because not one of them can define the word life in a way that he can use it consistently. Okay, that's going to be my point. Okay, so this fellow just says the following, and listen carefully. Here it goes. The questions and issues to be addressed in this rebuttal include: has anyone ever defined the word life scientifically? And is a listing of actions most living entities can do a scientific definition of life?
Life is defined as any system capable of performing functions such as eating, metabolizing, excreting, breathing, moving, growing, reproducing, and responding to external stimuli. Maybe actually check to see if anyone has defined the thing that you're claiming that no one has defined.
Okay, um, so he's got all these things that he says living things do. And that's more or less what you'll find out there. And biologists agree today that there is no real definition of the word life. It's just a listing of properties that they think that a living entity should do, but they cannot tell you what life is. They don't have a definition of the word life. Therefore, we don't have a definition of the word biologist, because biology is supposedly the study of life. And so let's start with this, with definitions, because you don't have a definition of the word definition. These people don't know what a scientific definition is. And so you look up and say, well, what is a definition? You know, we got to start somewhere. That's a good place to start, defining what a definition is to begin with. A scientific definition we're talking about here, not just for ordinary speech, but for science. Okay, so what is a definition? Well, here you have all these versions. Okay, I got these three versions from different places. The one on the left says there's like 7 or 8 definitions of definition. The one on the right says there's 5 at least types of definition. The one on the bottom says there's all definitions attempt to explain or clarify a term, and they have at least 3 definitions: formal, informal, and extended. So we have all these types of definitions out there, but again, they can't not define what a definition is. What does the word definition mean? What is a definition? So, we look it up, and here we have, I think it's from the Wikipedia. Let's see it. No, this is my version, sorry. We don't have a definition of the word definition. You can look it up yourself, okay? But this is what we're saying, that a definition is: a scientific definition, a limitation placed on the extent or usage of a word. That's the definition of the word definition, okay? Definition is not the same as meaning, okay? Definition is what a prosecutor proposes. Meaning is what the juror gets out of it. Okay? Meaning has to do with how a definition is interpreted. If a definition is on the emitting end, meaning is on the receiving end. A prosecutor issues definitions, a juror infers meaning. Okay, so that's our starting point. And here we have one fellow who tries to define life. He did his best, and he says, life may be a computer simulation. Okay, life's an illusion. Okay, life is just fantasy. Okay, those are the notions he's got. Sometimes I feel like I'm living a life of illusion. Okay, so yeah, different people have different notions of what life is or what a living entity is. This fellow thinks it's fantasy. Okay, life is fantasy. That's a unique definition. Here's another. These are the ones you'll find on the internet. I just put 4 of them because there's so many definitions. You'll see that in here. The first one says life is defined as any system capable of performing such functions, and you go through a list of functions. Another one has more or less the same thing, 7 characteristics. Another one says all living organisms share several key characteristics or functions. Again, they just mention a bunch of things that living entities do. But I like the last one, says as many as 123 definitions of life have been compiled. Loved it. We have 123 definitions of what life is. People have different notions. Like this fellow, he thinks it's fantasy. Okay. Illusion, that's life for him. That a living entity is one that has illusions, I guess, or lives in fantasy. I don't know. Okay, so we don't know what Life is, here's the definition, I think, from the Wikipedia, okay? Biology, the scientific study of life. No, in science, we do not just study. Anyone can study and not understand anything. So studying should not be used as a definition for anything, any branch of science. The word study should be eliminated. We don't study in science. In science we explain. Anyone can study, anyone can run experiments, anyone can do an equation. That doesn't mean they understand anything. Okay? Life, a quality that distinguishes matter that has what? Biological processes such as signaling, self-sustaining processes from that which is not, does not, and is defined by the capacity for growth, reaction to stimuli, metabolism, energy transformation, and reproduction. So if your grandmother does not reproduce, she's not alive. If your aunt can't reproduce, she never lived, she was never alive. Do all entities reproduce? How about two homosexuals? Can they reproduce? Are they alive? You know, all this is nonsense because this does not apply to every individual out there or to every living entity. Okay, not all entities reproduce, and if they don't, I mean, are they supposed to reproduce every day? And if they don't reproduce the next day, if the hen doesn't put an egg the next day, it's not alive. I mean, what is this? No, you cannot use the word reproduction to define life. Okay? Because it's not universal. That's why you cannot. So we have a different definition. We say biology is rational explanations related to living entities. What is a living entity? What do we mean by alive, being alive, right? A natural object that moves against the path of least resistance, primarily gravity. If you can move against gravity of your own free will, not like a rock that is thrown against gravity, but of your own free will, right? That means that it's a natural object, has to be one made by Mother Nature, not one made by humans. We can make little toy planes fly against gravity. We can make little robots that go up the mountain or pixels on a screen. Those are not alive because we're talking about natural entities that have the ability, their own personal ability, to move primarily against gravity. That's a living entity. And the first entity to be able to do that was the cell. Okay? Whether plant or animal doesn't matter because they all can move against gravity. Gravity says you move this way and the cell moves in the opposite direction. That's the point. So life is the set of living objects. And biology against the explanations related to living entities. Okay, we have a definition. And so now we are able to carry out a discussion. But to say that, it's that which reproduces and has children, and if you don't have children, that means you are not alive. And if you never had children, well, you never lived. I don't think that'll work for science, okay? Okay, let's get to the questions, comments people made. Couple of them here. One fellow says, the whole point of the famous equation E equals mc squared is that mass and energy are interchangeable. Everything is energy ultimately. Well, the problem with that is that Mr. Richard Feynman, I'm sure he outranks you. He got a Nobel, okay? He said it is important to realize that in physics today we have no knowledge of what energy is. So anyone using the word energy is introducing spirits. So to say that everything is spirit, well, we haven't said much. Sorry. No go with energy. Energy is a bad word to use, just like field, more or less, mass, all those words, time. We don't use those words in science. Those are four-letter words as far as science, physics, right, is concerned. Fellow says reality is merely an illusion, albeit a very persistent one. Okay, supposedly said by Albert Einstein. He also said what we have called matter is energy. And what do we just say? That energy, we don't know what it is. Okay? Whose vibration has been so lowered as to be perceptible to the senses. There is no matter. Well, if Albert Einstein, good old Einie, said that. Well, you know why he stuck his tongue out? Because he was out of his brain. He was out of his rocker. Okay, so yeah, uh, he was not a very intelligent person. Okay, all he did was make an equation and then give it the most irrational physical interpretation he could find, which is the bending of the concept, four-dimensional concept called space-time, which Stephen Hawking says is unimaginable. Yeah, you cannot imagine any concept. You have to define concepts. Okay, so space-time can be defined. It cannot be visualized. It cannot be grasped uh, through images because it's a concept. We don't grasp concepts through images like love or intelligence. Okay, and here's another fellow says existence question mark. What do you mean by existence? Fellow answers him, says exist, having objective reality. Poor word because reality is a synonym of exist, so that didn't work. But he had some very close. He says length, width, and height having position, location. I guess he got that from this site because nobody defines an object as having location being the definition of existence. We do in this site, so he got that here from here, no problem. You should give credit where credit is due, but we don't say it's length, width, and height. We say it's an object that has location. The problem he's got is that he puts having position, location. He defines location as position. So he goes around in circle. Obviously, he never learned to define words scientifically, and that's why he makes these basic errors. No, the way we say it in science is we say exists is physical presence. Okay, what is physical? It's an object. What is presence? Location. An object that has location, by definition, exists. That's the definition of the word exist. What is an object? That which has shape. Okay. What is location? Well, first you define distance, which is the separation between objects, and then we say location in the universe, right? What is the location of the Earth? Well, it's the set of distances, the set of separations from every atom in the universe, essentially. That's the location of the Earth. There's no math involved, no number lines, no measurement, none of that. We just say, what is the location? Physical location? Well, it's a set of distances to every atom, every object in the universe. That's the location of the Earth in the universe. Yeah? We don't care how much, we just care where it is with respect to everything else. Okay, and one fellow says, the final issue says, if the process of the ropes fanning out, we talk about gravity being the fanning out of the electromagnetic ropes that interconnect every atom in the universe. Okay, so one object falls or rolls around another, like the Earth around the sun. Why? Because the sun twirls the Earth around from all these electromagnetic ropes that bind every atom on Earth to every atom of the sun. Essentially, this is the situation, okay? This is why the Earth twirls around the sun. My hand is the sun, and the ball is the Earth, okay? The Earth is bound. Every atom on Earth is bound to every atom of the sun. So the sun twirls the Earth around, and that's why, and space is nothing, so the Earth cannot rub its shoulder against space. That's why the Earth goes around the sun forever and ever and ever. Not really forever. There are some conditions there as well to consider. But the issue is the reason the Earth goes around the sun is that the sun twirls the Earth around itself through the countless electromagnetic ropes, right? Which are intangible and invisible. Ropes go right through ropes. Mother Nature does not have ropes touching ropes. And until you get that square in your head, you're going to have a lot of trouble, at least on this side. Anyways, he says, process of the ropes fanning out makes the ball fall. Then what causes that process to start in the first place? Well, this is the answer. The answer is the universe is an eternal pinball machine. Now, the pinball, you have the guy shooting the first ball, right? And then it goes and hits and goes around, right? But think of it as it's just perpetual motion. So you're talking about What's the origin of motion? That's essentially what you're asking. That's ultimately what you're asking. There is no beginning to motion. Okay, there is no beginning to motion. And so everything is already moving in the universe, right? And now we're just going to look at one case of that to find out why that thing approaches something else. Gravity, fanning out. And we're just saying, the asteroid approaches the Earth or the moon or the sun, whatever. And why is it falling towards the Earth? Well, because again, the ropes are fanning out. That's why that asteroid, that specific, we're just going to chop that situation, that predicament, that thing from the rest of the universe. We're going to say, why does that asteroid fall to Earth? That's all we want to understand. Okay, and we're saying that the ropes fan out. You say, well, what started the asteroid from moving? What kick-started it? And again, everything in the universe is moving. Nothing can stand still, not even God. I want to move God since every atom of God, if God exists, right? What is existence? Means physical presence, means that God is not only an object, okay, but every one of his atoms is bound to every one of the atoms in my body. So all I have to do to move God is move my finger. I move my finger and God moves with respect to my finger, whether he likes it or not. So he can be all powerful. He can live in the fifth dimension for all we care. But I can move God anytime. I can change the distance of every atom in my hand to every atom in his body, if he exists, right? And I'm moving God right now because every atom in his body is moving with respect to every atom in my finger. Everything in the universe moves. Was there a starting point? Was there someone who kick-started and put everything in motion? Well, that was known as God until he stopped existing. When God began to exist, well, he couldn't get anything started. Yeah, God, if you're going to put him in there, he's got to, if he wants to exist, God wants to exist, he's got to be an object first, and then he has to have location, which is the set of distances with respect to every atom in the universe. If he doesn't have those two conditions, God does not exist by definition. Not because I believe or stop believing in him, he wants to exist. He just has to follow the rules, and the rule is, he's got to be an object and he's got to have location. With that, I'll see you next week, next Sunday. We'll see you then. Bye-bye.